Okay, folks, now let's talk about section 5.2. This is one-to-one functions and inverse functions. Let me take you back a ways and have you recall the definition of a function. I've got it a little bit paraphrased here. Recall that a relation, an input-output relation, is a function if each input has just one output. Each input has a unique output. And recall how we could locate functions quickly or tell whether something was a function from the graph. Vertical line test. Remember the vertical line test? So here's the relation y equals x squared, our familiar parabola with vertex at the origin. And the vertical line test just said if all vertical lines, or if any vertical line cuts the graph of y equals x squared in at most one place, then this is a function. If a vertical line cuts the graph in more than one location, then that gives you a place where there's an input for which there's two different outputs at least, and it's not a function. So let's see, looking at vertical lines here, they cut at most one place, so yes, y equals x squared, or now I guess I can use function notation, f of x equals x squared is a function. Okay, now that's old hat. Here's new hat. A function is one-to-one if each, now I want to reverse this, not each input, but each output has just one input. So we're taking a definition very similar to the definition for functions that said each input had to have a unique output, but now we're turning it around and saying we'll even call it a one-to-one function if it has the characteristic that each output has a unique input. And how would you tell that if you were looking at the graph of a relation? Well, we will now have the horizontal line test. And let's apply that to this same familiar toolkit function y equals x squared. The horizontal line test, I don't even think I'll bother writing it out on the board. It will say a function is one-to-one if no horizontal line cuts the graph of f of x in more than one place. So the horizontal line test is exactly like the vertical line test, only substitute the word horizontal, and instead of testing to see if something's a function, you're testing to see if it's a one-to-one function. So here, of course, you could look at horizontal lines, and some of them don't cut the graph at all. And there's a horizontal line right here at the x-axis that gets just the vertex. But if you can find even one horizontal line that cuts that graph in more than one place, then nope. F of x equals x squared, not one-to-one. Actually, you can relate this very clearly back to the definition. Maybe in this specific parabola that we know about, that might be the point 1, 1, and this might be the point negative 1, 1. Here's two different inputs rather, negative 1 and 1, that have the same output, positive 1, and that violates the definition of one-to-one. Each output is supposed to have just one input, but here's an output, 1, y equals 1, that's got two different values of x associated with it, not one-to-one. Okay? Remember back when we defined functions for the first time, we looked at some relations and functions that were defined just by sets of ordered pairs. So let me give you an example like that you will see in the homework here. So let's see, right down here, is the input-output relation defined by those three ordered pairs, or those 3 points in the plane. Is that relation a function? And recall, you would look and say, well, let's see, what do I have for inputs? 2, 1, and -1, 3 unique inputs. And 2 only goes to 7. I don't have another ordered pair here that says 2 goes to 7 and goes to -7 or 12 or 15. 2 has the unique output 7, 1 has the unique output 7, -1 has the unique output 3. That's a function. And remember, the quick way to see that was just that looking at the x values, they don't have 2 different points or more than 1 point with the same x value. So each x goes to just one value of y. Yes, function. You can anticipate my next question. Is it 1-to-1? And here, instead of looking at values of x, look at values of y. 7, 7, 3. Oops, I've got 2 different outputs here. I'm sorry, 2 different points where the same output, 7, is trying to have it 2 different ways. It's got inputs of 1 and 2. And so this is not 1-to-1. And if you would look at a graph of this very simple relation, it's got points at 2, 1, 2, 3, 4, 5, 6, 7 up here, and it's got a point at 1, 7, and it's got a point at -1, 3, and there are the 3 points. Notice those 3 points satisfy the vertical line test, so yes, it's a function, but fail the horizontal line test in just this one place. The horizontal line y = 7 cuts that 2 places, so not 1-to-1. Okay, so why do we care about 1-to-oneness? Why is this an important